Some vocabulary. Ordered pair. Two numbers used to locate a specific point on a coordinate grid. Ordered pairs can also be called coordinates. We show these with an x and then a y, and we usually put parentheses around them. The first x, or the first number, is the distance on the x-axis, which moves left or right. Second number is distance on the y-axis, or up and down. So if you have an ordered pair like 1, 5, you'd move to the right 1, and then up 5. Again, because it's x, y. Distance on the x, distance on the y. Left, right, up, down. So right, 1, up 5. 5, 1 would be moving to the right 5, and then up 1. Negative 5, negative 1 would be moving to the left 5, then down 1. Direct variation, when two quantities have a constant ratio. In other words, as one value goes up or down a certain amount, the other value goes up or down by a constant. We often hear people say the two values vary directly. Origin is the point on a graph with the ordered pair 0, 0. Sometimes we see it in the center, sometimes we see it in the lower left. It depends on which quadrant or quadrants we're looking at. Constant of proportionality is the constant ratio between two values in a proportional relationship. So here you'll see number of oranges compared to number of apples is 1 to 3. The next one, 2 oranges to 6 apples reduces to 1 to 3. And 3 oranges to 9 apples still reduces to 1 to 3. So 1 to 3 we would call the constant of proportionality for this situation. How to tell if there is a proportional relationship? One way is to look for equivalent ratios. So I'm taking the data in the table and scaling up. So 3 times 2 is 6, 1 times 2 is 2. If I multiply the 1 over 3 by the same thing, like in this case 3, I get 3 over 9. As long as I multiply or divide the 1 over 3 by the same thing, I get an equivalent ratio. Or I can take any data in the graph, like 5 over 15. If it reduces down to 1 over 3, those are equivalent ratios, and we're dealing with a proportional relationship. Another way to tell if you have a proportional relationship is if you look at a graph of the data. So here I'm going to graph all of the data, number of oranges to number of apples. If the graph of the data can be represented by a straight line that passes through the origin, then you have a proportional relationship. I'm going to do the best I can to draw this straight line here. A little shaky. But you can see it's a straight line when I connect all the points, and it passes through the origin. Here's how to calculate the constant of proportionality. If you have a word problem, one way to do it is just to read the words carefully, 1 orange, 3 apples, and make that a ratio, 1 to 3. Or if you calculate several values, let's just take one, 6 over 18. If you know it's a proportional relationship, if you reduce that down, you'll eventually end up with the constant of proportionality. You can also find the constant of proportionality by using a graph. Now remember, the points are x, y. Now a lot of times the constant of proportionality is represented by the variable k. And if we take the y value over the x value, we'll get the constant of proportionality. So you can take a single point, like 6 comma 2. And again, we're going to put 2 over 6 because we're going to put y over x. And if we reduce that down, we get the constant of proportionality. So again, I just took the y value over the x value. I got 1 to 3 again. Now another way to do it from a graph is if I take 2 points. So I'm going to take the 9 comma 3 and the 3 comma 1. Again, I'm going to use k for the constant of proportionality. This time I'm going to subtract the y values. So 3 minus 1, those are the y values in those 2 points. And then subtract the x values, 9 minus 3. 3 minus 1 is 2. 9 minus 3 is 6. And that reduces down to the constant of proportionality, 1 over 3. So again, I can take it from 2 points if I know that it's a proportional relationship. So creating an equation using the constant of proportionality, again, the k represents the constant of proportionality and y over x. Now one thing I can do is multiply both sides times x. The x's cancel out. So another way to write that equation is y equals k times x. So now I can use those two equations to find other values. So right now I'm substituting in the 1 over 3 constant of proportionality and substituting in 1 for y. So I can use this to figure out if there's 1 orange, then there would be 3 apples. I could also use this to find other values, like if the 1 were a 2, again the constant of proportionality is 1 over 3 equals 2 over what? Again, we could scale up or cross multiply. It's 2 over 6. If I put 9 in place of x, again I could scale up and find that the number of oranges would be 3. 3 to 9. Using the other equation, y equals kx, I'm going to replace k with the 1 over 3. That's the constant of proportionality. I'm going to replace x with 9. And if I multiply 1 over 3 times 9, I'm going to put a 1 under the 9. 1 times 9 is 9. 3 times 1 is 3. And that reduces down to 3 over 1, or just 3. I get my value for y. So now let's use this to calculate for 12 apples. I replace x with 12. I do 12 times 1, that's 12. 3 times 1, and again the 1 is underneath the 12, is 3. 12 over 3 reduces to 4, so that tells us y equals 4 when x equals 12. Now going the other way, if we're given the y, if in this case 5, I'm going to replace y with the 5. And I want to find x, so I need to get rid of the 1/3. So I'm going to divide by 1/3. That cancels those out. Now 5 divided by 1/3, I'm going to have to do copy, change, flip, or multiply times the reciprocal. So keep the 5 times and then 3 over 1, and that turns into 15 over 1, which is just 15. So when y is 5, x was 15.